Hi folks, it's Mr. Defy. Welcome to a session about linear inequalities. In this video, I will give you two examples of how to graph and analyze a linear inequality. So let's go ahead and jump right in. In example one, you can see that this linear inequality here is already set up to go. So this takes on the form of something that you might have seen before called slope-intercept form. So slope-intercept form is y equals mx plus b. Okay, now this is not an equation. It is an inequality, but the way it's put together is very similar to this y equals mx plus b, and it shares a lot of the same components. The b, to remind you, is where you begin, and where you begin on the inequality here is at a 5. Now this 5 represents a point on the y-axis. It's never on the x-axis because this is our y-intercept. So I begin here. So going up to 5, I put a point and then I wait there. My slope, which is my m, tells me how to move from where I began. And this is always based on a change in y over a change in x, where the way you read this fraction is top to bottom, meaning the y is what you talk about first. So that's what you have to first do. Either go up or down from this initial 5 point. Okay? Now my slope over here is negative 1 over 3. I'm going to pull this out here. When the negative is in the middle, you can put it wherever you want. So I could make it negative 1 over 3, or I could make it 1 over negative 3. The only difference is in how it tells you to move. So this would tell you to go down and to the right, whereas this would tell you to go up and to the left. And the only reason it's good to know that is because depending on the amount of space you have, you may have to do one or the other. So if I look at my initial point, my 5 over there, what I see is that I'm really high up and I'm close to the border of my coordinate plane. And I can't leave that space. I have to stay within it because I don't want to guess where the squares are. If I were to go up 1, I would just be there. I'd just make it. But I don't want to just barely make it in. I want to actually be comfortably inside. So I'm going to go down 1 and then to the right 3 times. So 1, 2, 3. And I'll put my next point right there. So I can go ahead and make my line, which would look something. Well, actually, before I make my line, I need to look at my inequality. So my inequality, which is here, tells me the type of line that I need to make. Now, one thing that you want to know is when you have symbols like this, you always have an open circle, but you also have a broken line. And the reason is, think of it this way. If you put a bunch of these open circles in line together, your line would not be a solid line. It would seem to be sort of broken in places. Whereas this and this create a solid point. They therefore also create a solid line, because if you put a bunch of these points in line together that are closed up, you would get what looks like a solid line. Okay, so keeping those things in mind, if I look at my inequality here in the question, it's greater than or equal to, which means I will definitely have a solid line. So I'll go ahead and do that right over here. It's not the straightest line, but it's enough to make my point. And then before walking away, I need to do one more thing. Now, inequalities are different from equations in that with inequalities, you have multiple solutions. And we need to represent all the possible solutions that we can have. The only way that we can do this is by shading an area on this coordinate plane. And to know where to shade, whether it's above, over here, or below, over here, we have to test a point first. And the best point of all to test is your origin, which is right there. And the reason why it's the best is because it's 0, 0, and zeros are easy numbers to work with. So I need to test those numbers, which each represent my x and y, on this inequality here to see what it is I actually get from that. So here I go. I'm going to do a quick test of 0, 0. So plugging in my x and y, I get 0 is greater than or equal to negative 1/3 times 0 plus 5. Now, the nice thing about zeros again is that it simplifies our work. 0 times anything is 0. So that part is gone, which leaves me with a statement 0 is greater than or equal to 5. And I have to judge whether this is a true statement or not. 0 is not bigger than 5, nor is it equal to 5. And for that reason, this is a false statement. Because it's false, that means that this point right here at the origin represents an entire area of points that are never going to work with this inequality. They will never make it into a true statement. So this 0, 0 was the representative, and it failed. It failed to negotiate that area. So if this side doesn't work out, if this side is false, that can only mean one thing, that the other side of the line must have a bunch of ordered pairs, which would make that inequality true. And so to represent that, we simply shade everything above that line, like that. Okay? So all the solutions that you could possibly have for that inequality lie in there. So all solutions lie in here. And remember that this coordinate plane expands to infinity. So as long as this line continues forever, so will that orange shaded area. It will grow as the pink line grows, so will the orange area. And so will the number of solutions to that inequality. So that's the first example. In the second example, we have another inequality, but this inequality is not ready to be graphed because it's not in slope-intercept form. We could create a table and generate our ordered pairs from that, but if you want to create a quick graph, it might be good to change it into slope-intercept form, which is also good practice for other things like solving an equation. So what I'm going to do is pull this aside and change it into slope-intercept form. Okay, so we have 3x plus 2y is greater than or equal to negative 2. Now, to change it to slope-intercept form, just remember your equation solving skills. I will take this 3x and move it to the other side like this. That leaves me with a 2y greater than or equal to negative 3x minus 2. And then I simply have to divide by 2 everywhere. And what I get is y is greater than or equal to negative 3 over 2x minus 1. Now this is ready to be graphed. And again, like in my last example, you start with the y-intercept. That's the number that tells you where to begin. So I'm going to begin at negative 1. And again, this is on the y-axis. So here's my negative 1 point, and I wait there, and then I look at my slope. This tells me how to move. Now I have negative 3 over 2. So this is my change in y, this is my change in x. And so my change in y is telling me, take your y and move down 3 levels from where you are right now. So I'm going to move down 3 levels and then 2 to the right. So doing that, I get the following. So 1, 2, 3, and 1, 2 to the right. Where I stop is where I put my next point, which is there. And then before making the line, I need to consider the type of line that I'm going to create. This line will be a solid line because, once again, I have greater than or equal to. Okay, and that equal part means that the line will be composed of solid points. So here's my line. I'll get rid of this and this. Oh, that's way off. Let me do that again. There, that's better. And I'll stretch it out as far as I can. There you go. Now, this is not the end because I need to shade an area which represents all the possible solutions to this inequality. So I need to test a point. Now, the best point, again, is the origin, which would be right here. I'll make that a different color so you can see it a lot better. Okay, so right there, I'm going to test 0, 0. And I'll do it here at the side. So testing 0, 0. My x is 0, my y is 0. So what I get is the following. I get 3 times 0 plus 2 times 0 is greater than or equal to -2. Well, again, the nice thing about zeros is that it has a way of wiping out numbers real fast. So this is gone and so is this. What I'm left with is a statement 0 is greater than or equal to -2. And yes, I do need to put a 0 right there, because if I don't have a number on both sides, then I don't really have a statement. So please put that 0 if that's all you have left over on one side. And then I look at this statement and I think, is 0 a number that is greater than -2, or is it equal to -2? And the answer to both is no, it's not. It's neither greater, or actually, I'm sorry, the answer is yes. 0 is greater than -2, though it's not equal to it. But the fact that it's greater than -2 means that, yes, yay, this is a true statement. And because it's true, what that means is that this point 0, 0 represents an entire region of points, which would make this inequality here a true statement. Every time you test out the x and y from any point in this area, it would make this a true statement, just like 0, 0 did. And so I need to represent all the possible order pairs that you could have in that area. So what I will do is simply shade everything in. Okay, everything gets shaded in. And there you have it. So all the solutions that you could possibly have are sitting in there. All solutions in here. And like I said before, this green area will expand and grow forever as the pink line continues in both directions forever. So you have an infinite number of ordered pairs which would each be a solution to this inequality. It would make it a true statement when you substitute and test out your x and y coordinates. So I hope this video helped you out. Please stop by, leave a message, leave a comment. Please make sure it's constructive. I always appreciate constructive criticism from anybody. And like always, thanks for taking the time to stop by and watch. Take care. Bye-bye.